of 6 is systems. Yeah, we're going to go back and go through all of those after Thanksgiving break. It's different ways of solving systems. So we're dealing with systems of linear inequalities today. What this means is we're going to graph two linear inequalities on the same coordinate plane. Okay, so we're going to do what we did with the end of chapter 6 with the shading, the dotted line, the solid line, all that stuff. We're going to do two of those or more on the same coordinate plane. So really not too bad if you can graph an inequality. These are not too bad. So let's start with this one. Y is greater than negative x minus 2. And the second inequality is y is less than or equal to 3x plus 6. Okay, so we're graphing linear inequalities out of that. All right, so if we're going to graph linear inequalities, we need those inequalities to be in what form? Are they in that form? Yes. So I'm ready to graph them. So coordinate plane. Now I'm going to graph this first one with the red line. What's its y-intercept? The first inequality. -2. So I'm going to put a dot there. And then how am I going to count my slope? Up one, left one, or down one, right one. What kind of line should this one be? It's got a negative slope, but dotted or solid? And why? Why is it dotted? Doesn't have the equal to mark, so that's what makes it a dotted line. And then we need to think about shading on that. Okay. So how did we do shading back in chapter 6? All right. So plug in the test point 0, 0 is what Adam's telling us to do. So we're plugging in 0 for y and 0 for x. So we have y is, or 0 is greater than -2. Is that true or false? Is 0 bigger than -2? Yes. So that means we'll shade toward the 0, 0. So your pencil just lightly shade. You don't want to shade too dark here. Just very lightly shade that side of that line. Because you still got to graph this second one on this same coordinate plane. So you got to still be able to see. So just kind of lightly shade, or just maybe put a little squiggle on that side saying that's where it's at. Now let's graph the second one. What's its y-intercept? +6. I'm gonna graph it with a blue line. 1, 2, 3, 4, 5, 6. Slope 3, so I could go up 3 and over 1. Be about right there, or down 3, left 1. Should that be a dotted or a solid line? Solid. Why is it solid again? It's got the equal to mark, so that makes it a solid line. So we're going to draw that solid line. And then we got to do the shading for that. So I'm going to plug in 0, 0 because the line doesn't go through it. So it's 0 less than 6. Yes, so that means I'm going to shade towards 0, 0. So this kind of the right-hand side of that blue line. So that would be this side. These are little highlighter things on this program so it turns the overlap a different color. What you're looking for is the darkest area of the graph, or the overlap. That is the solution area. That area right here where they overlap is the solution area. So it should be the darkest part of your graph. And if you want to use highlighters, if you got two different, like a blue highlighter and a yellow one, they'll mix as well on regular paper. Not quite as nice as that does, but I mean, it does do pretty good with blue and yellow. The other colors really don't mix too well. If you have blue and yellow, they will do that. So all of those ordered pairs in that green area are the answers to this. So the whole graph is what I have to have. I don't have just an ordered pair as an answer like we did yesterday. Yesterday we had one ordered pair. If there was, or it was no solution, or it was infinitely many. Okay, this, you're going to get that whole graph is what we got to see to have the answer. And that solution area is all of this overlap. Okay. Look at another one. Let's say we had x plus 2y, excuse me, is less than or equal to 4. And then y is less than, let's change that to greater than or equal to, just to make it a little bit more interesting result. And then x is greater than -2. So we have x plus 2y is less than or equal to 4, y is greater than or equal to -1, and x is greater than -2. All right, so we're going to graph 3 of them on the same coordinate plane. Is that first one in the right form? No, so we got to do what? Yeah, move the x. That's going to give us 2y. It's less than or equal to -x plus 4. And then divide by 2, right? That's going to be y is less than or equal to -1/2 x plus 2. That's in the right form. These others are just y and a number and x and a number, so they're already okay and ready to graph. So let's just go ahead and graph them. So that first one, the y is less than or equal to -1/2 x plus 2. What's the y-intercept? 2. So we're going to go to 2, and we'll go down 1 over 2, or up 1 left 2. That be a dotted or a solid line? Solid line. Can I test 0, 0? Yes, because the line doesn't go through it. So is 0 less than 2? Less than or equal to 2? Yeah, 0 is less than or equal to 2. So that means I want to shade toward the 0, 0. So that would be this direction. So I'm lightly shade that side of that line. I'm going to use a highlighter. It's easier to see the rest of the grid. If I do the lines, I can't see the grid. So that side of that line. All right. Now let's graph y is greater than or equal to -1. What's that look like? Horizontal line. Y and a number is horizontal. Go to -1. Should it be a solid or a dotted horizontal line? Solid, because it's got the equal to mark. Now shading for that one, it says y is greater than -1. Where are the y values that are greater than -1? Above or below? Above. So that's the direction we're going to go. So we're going to shade above. If it were just these two, we'd be done. That'd be the overlap would be, this kind of shape right here. But we've got one more to go. We got x is greater than -2. So that one's going to be what kind of line? Straight up and down vertical line at -2 on the x-axis. I'm going to graph it with a purple. And then dotted or solid? Dotted this time because it doesn't have the equal to mark. So this is where having a soft hand with the shading can help. And then it says x is greater than -2. Where are the x values that are greater than -2? To the left or to the right? To the right. So that means we're going to shade this direction. Okay, so if I shade that with the pink highlighter there. Where are the answers at? Yeah, that triangle in the middle, that black triangle there. That's what we're finding. So the solution area. Pen is acting crazy today. That'll fix it. There we go. So the solution area is this triangle in the middle. So we're just looking for the overlap of our graph. That whole graph is going to be my solution, or the answer that I'm looking for here is where are they overlapping. It doesn't get any more complicated than those. Really, that is as hard as they get. Having more than 2 on a coordinate plane, 3 is the most you'll have. You get into Algebra 2 and college algebra, we'll get more of them on the same one. We'll do some different kinds of graphs there, but for Algebra 1, that really is as tough as they get for this section. All right. Okay, so this is what you'll be doing when you get back from lunch and before lunch on page 469, numbers 9 through 20. 12 graphs. Okay, that's what I'm looking for. 12 graphs out of that. They're not very difficult. So.